Hey, this is Mayo, and I'm going to be talking briefly about how do you chat with your documents privately. So you've got data that you've got on your local computer or just private information you don't want external entities to see. How do you do that? So here in this example, I've basically got the NVIDIA's earnings calls, their most recent earning calls. It has their financial information. Obviously, this is public data, but let's pretend this was private information. So it has the revenue and all the different analysts asking these different questions about why they've grown so quickly. And it's quite a lot to go through. Now, if you see my previous videos, I go over the process of how to chat with your documents, chat with your PDF files. But the difference now is instead of using these closed models like OpenAI, we're going to be using open source models. I'll explain how in a second. But for the sake of this demo, I'm going to open up my terminal down here. And basically what I'm going to say is, what is this document about? So we're just going to wait for a second or a couple of seconds, and I'll explain why it might take a little bit of time. Let's go. Here we go. So now we're getting the results back. It's identified that this is an earnings calls transcript for the first quarter of 2024, and that it's discussed its financial performance as well as information and competitive landscape and partnerships. And here we can see the actual reference to the source documents and the different chunks that it's getting the information from the source documents, just like we've covered in previous videos, except that this time you'll get is internally. Maybe I want to ask a different question. Here we go. Growth driver for NVIDIA's revenue is driven by their accelerated computing platform worldwide, and it's picking up on gaming sales. So let's as it's printing out, let's look at the docs and see if we can pick out keywords. So it says 40 series, which it picked up from here. Strong sequential growth was driven by sales of 40 series GeForce GPUs. Have also contributed, and he talked about generative AI, which I believe was mentioned as a key driver earlier in the earnings calls as well. So it was able to pick up on that as well and provide the reference chunks where it got the information from. You can also see it picked up on the record revenue as well, if I was going to ask a question about that. So this is just a sample of what this looks like locally. So let's kind of hop over to the diagram. Okay, so if you watch my videos already, or you've kind of gone through this process of building a chatbot, or at least understanding the process, just a quick overview. This is a very simplified version of what I've covered in previous videos. When you want to chat with your document, your data, you start with your docs, you split them, you send them to an embeddings model that converts your text to numbers, because that's what the computer can understand. And so once your docs are in numbers, you store them in some sort of database called vector store. And then when you ask a question, like you saw me just doing this demo, the question is then sent to the embeddings model that converts the questions to numbers. Now you have numbers in here. Your question has numbers. You perform something known as similarity search. You can just think of it as a mathematical equation to figure out how similar the numbers you're asking are to the numbers stored. And those similar numbers in the vector store are retrieved alongside the text, which you saw as the source documents returned. It's passed as context. There's a plus here because we pass the question and the context to the model, which is typically OpenAI. And then we get a response, which you also saw. Now, when you want to chat with your data privately, there are a few components here that we can tweak. And before I kind of carry on to explain that, why would you want to do that? Now, obviously, the first one that kind of comes to mind is data leakage, right? This is the first thing that's going to come to mind in terms of why you want to chat with your data privately, is that you don't want the data to leak. Maybe you have some sort of IP or private customer information, or maybe just regulation of your part of the world. You don't want to get into trouble sending data off to OpenAI, any sort of third party. So this is the problem with the architecture. In terms of the architecture is fine, but in terms of the components, here, and here, where in previous videos I talked about using OpenAI and maybe something like Pinecone. These are third parties that hold your data. They do have terms where they suggest that they would not process your data, but people don't want to take that risk, especially when it comes to IP. The second challenge or problem with the closed model route is you have lack of customization. You know, what if you want to fine tune for your specific use case? What if you want to be able to customize something about the model, the way the model runs? You don't have as much customization because it's a closed model, and they control the pricing and they control how you can do certain things. The third reason, internet connection required. Now, if you're in parts of the world where you don't have access to constant internet, or data costs are high, etc., using the closed models, it can be costly and very difficult to do that if you're in those parts of the world. And even if you're not, the convenience of being able to use an application without internet is very useful. The fourth reason is server overload. If you've ever used OpenAI and you've run into situations where you have an outage and then you can't use it because too many people are using it, or it's just not consistent because the server is overloaded by too many requests. Again, if you're running things locally, you control the server, so there's no overload. And the fifth thing is lack of control. We've had a lot of recent changes to closed models like OpenAI, that have changed the quality of results, or there could be limitations on how much you can request per request, how many messages you can generate, and so on and so forth. You don't have control over a closed source model, and you risk vendor lock-in, right, as well. Now, there's pros and cons of going down the open source route, which I'm going to talk about in a second. But this is just a touch point of 5 things that kind of stick out to me in terms of the problems with the closed source components. And so what do we do? Well, let's start here, right? Well, the model to convert the docs to text, convert the docs to numbers. Originally, we would use like an OpenAI's embeddings model. Well, we can swap this out for this, right? We've got something like this, which is sentence transformers in Hugging Face. It's open source, and yeah, there's installation instructions. I have a repo that I'm going to share that basically you would get all of this, but the open source version. But I'm just going to take you step by step. So we have the sentence transformers, which are open source, and they take your text and they turn them into numbers. So that's that. We replace this with an open source alternative. The vector store, rather than use something like a Pinecone, you can use something like Chroma DB, which is a AI native open source embeddings model. Again, you can, they basically have docs and installation, but it's all local, right? You store the embeddings locally, and I'll show you in a second how that works in the code base. The third component, which is the most important as far as this discussion is concerned, is replacing OpenAI or any sort of closed source model with an open source model. Now, there's been a lot of open source models that's come out, but personally, based on the testing I've done, I would say this is the best one so far. Mosaic's MPT-30B. It's open source, it's commercially licensed, and basically it outperforms the original GPT-3. So you can see in the documents, in the announcement here, they have 3 base, instruct, and chat. They go over the performance and the evaluation. But I've been very impressed with how it performs. But obviously this is a pretty big model, 30B. So what we can do is use something known as GGML, which just basically allows you to run large language models on your computer. And so you have this individual here called the bloke in Hugging Face, who has provided the GGML version of the this model, which is an open source model. And so we're going to be downloading one of them here. You can see the size is pretty big, but once it's on your computer, it's on your computer and you can run it locally. There's no data leakage. You don't need internet, and it's impressive. And so, in a nutshell, we will just cross this off, right? And instead of, let me just make this a bit presentable. And so, instead of an OpenAI, right, we would, let me just take this out of the picture. Instead of an OpenAI, we would have maybe something like a MPT-30, right? Basically an open source LLM. So we would have 3 touch points, right? The open source model, we would have an open source vector store, and we would also have open source embeddings. And so if you do that, then you end up with basically a completely private interaction with your documents without any sort of data leakage. So let's jump into the code, and I will just walk you through. Now, to download this, you will just literally follow the repo link that I share. You can go through the README. I've gone through the steps of installation, cloning, downloading the model. Basically, you can upload these different file formats, so PDF, TXT, CSV, doc, etc., and instructions for how to chat with the documents. I've basically provided all of that for you. Credits to Abacaj, Martinez, and the bloke as well. Yeah, those are the 3 inspirations for putting this together. So just exit this. So yeah, now I'll just do a quick walkthrough. So here, first of all, you have the structure. In the question answer docs py is just the logic for the chatting with the docs. Here in the chat.py is just if you want to just chat with the model without chatting with docs, and this is a lot quicker. I have a download underscore model.py. Basically, it's a script to download the model from Hugging Face that I showed you earlier, and you also have some other things going on. So the main thing is, once you've copied, made the clone, here in the source documents, you can see here I've got NVIDIA by default. You can remove this and put in your own documents. Once you do that, and you've done the installation, you want to ingest, right? So this is the script for ingestion, all done for you. I've got makefile, so all you need to do is run make ingest. You would just do make ingest like that. If you want a shorter way, rather than poetry, run python ingest.py. And so what that's going to do is go in the source documents. All the files in the source documents are going to be ingested through the embeddings model. You can see here, rather than using OpenAI, we're using the Hugging Face embeddings, which we specify as the sentence transformers that you saw earlier. So the ingestion is you done doing Chroma and Hugging Face embeddings, so it doesn't leave your system, right? There's no leakage with this approach, but all of this logic handles that for you. Once this is done, a DB folder is going to appear, and it's going to contain the embeddings, right? Locally. Again, you can store these embeddings somewhere else if you want, but this is where the default embeddings are going to appear. Once the DB folder is there, you want to download the model. And so here I've downloaded the model. You can see MPT-30B chat bin, and you can download in two ways. You can either run the script here, which you can see, again, I have a make file. So if you wanted to make it simple for yourself, you would just do make download, and it will just run this script for you, right? Then you download this whole thing. It's going to store in a models folder here. And yeah, so it's going to do that. Bear in mind, this is 19 gig, so it's going to take a bit of time. So yeah, once you have that locally, that's the large language model is now in your system. Here are the environment variables you probably want to copy over. Again, this persist directory, which is DB here, model path, which is here, embeddings model name, this is the sentence transformer, and target source chunks is just basically how many relevant docs we want to pull back when we make a search. And that's it basically. When we want to chat, for example, or let me go to the utils. Yeah, basically we have a default system prompt, conversation between a user and LLM AI system. You can change this. And then this is the recommended format, which is already pre-done for you for Mosaic. It has its own syntax for that. And so if we go in the question answer doc, .py, we use langchain, streaming, and retrieval QA chain, which just helps you to do question answer over docs. And langchain also has something called C transformers, it's just basically a Python bindings for basically allowing us to work with the GGML files as well. And again, you can see when the question is asked, we use the open source embeddings model as well as the open source vector store to do the QA, right? So it's basically very similar to what we would typically do. You can set your own config here, temperature, stop sequence, and the same in the chat as well. Temperature, top gain, and all these things, max new tokens. It's similar, but the difference is here we are replacing the closed components with open source components. Now, what I will say is, based on testing this, the accuracy is pretty good. I'm very impressed with the accuracy, but I will say that the speed isn't quite there yet. I mean, some queries I've made have taken even up to 5 minutes to come back, sometimes 3 minutes. If you just use the chat without the docs, it takes probably around 30 seconds, sometimes 20 seconds. So if you just ask simple questions like what is music, or what is just simple chat questions. But when you want to use this, because basically it's going to do a similarity search, and then it's also going to pass in its context, you're running this locally, what I've noticed is the target source chunks make a huge difference. The less this is, the quicker it returns. And also, the less complicated your question is, the quicker it returns. And you also, I would, and I put this in the README, I think I would suggest 32 gig is the minimum RAM you need to run this, right? Anything less than that, you might have to use maybe a smaller model. MPT has a MPT-7B, which is a much smaller model than this, and it'll probably work on your computer. But as far as the 30B, I would recommend at least 32 gig of RAM. If you also want to run this in Docker, it'll probably make it easier for you as well. So pros and cons, but this is very encouraging. It's definitely a move in the right direction in terms of democratization of these models. And yeah, the main thing here is make sure you've got a system that can handle this, and just try and keep the scope low. Don't try and return too many chunks or do too many documents. Otherwise, it's going to take a long time. And yeah, just have the right expectations. It's not going to be super quick at all, but I expect that over time, these local models are going to get much more quicker and more accurate. So that's it in a nutshell. You can download this repo, tweak it. It's MIT. And by the way, the chat of the MPT model is non-commercial. So you cannot use this for commercial use. You can use the base and instruct. All right. Cheers.